Okay, welcome back. Quantitative research methods. We're still in Module 10, and this is basically 10B. We're going to talk about hypothesis testing. It's a follow-on from our talk in Module 10A related to significance. So, hypothesis testing. Statistical significance is used to test hypotheses. So recall, when we talked about hypotheses, recall that we have two hypotheses that we're interested in. One is the research hypothesis, and the other is the null hypothesis. And the null hypothesis is essentially that there's no relationship. Well, I'm going to hypothesize no relationship between variables. Whereas the research hypothesis typically is that we will find a relationship between variables. And that's what we use statistical significance for, to test whether there's a relationship or whether there's no relationship. And this is just the notation for the null hypothesis. So we use significance to test these hypotheses. And you know from previously that statistical significance is annotated as a p-value. When the p-value, or is the probability of being wrong, of having the research hypothesis be wrong, probability of being wrong, that a relationship exists. And we could be wrong. And what that's called is a type 1 error, meaning that we could hypothesize that a relationship exists when indeed it doesn't. So we would, type 1 error is that we think that there's a relationship, that as hours spent studying goes up, so does GPA. We could hypothesize this and be wrong. And if we're wrong and truly there's no relationship between hours spent studying and GPA, that would be called a type 1 error. Okay, so we're going to hear more about that in a second. When the probability or the p-value or the significance is 0.05, less than or equal to 0.05, we reject the null hypothesis. So if we find that our relationship is statistically significant, we reject the null hypothesis. Because essentially what we found is that our research hypothesis is true. If the p-value is greater than 0.05, it's not statistically significant. Not, and I like to abbreviate that as not sig. And if you have that finding, if it's not statistically significant, you cannot reject the null hypothesis. So it's kind of a backwards language for hypothesis testing, but that's what convention is. All right, let's look a little bit more at this. Let's look at those types of errors. What is this crazy type 1 error? Well, just to define it, it's a risk. It's a risk level. It's the error of being wrong about the research hypothesis, when in fact the null hypothesis is true. So we hypothesized that as hours spent studying goes up, GPA goes up. And we find that this actually is not true, that there is no relationship between hours spent studying and GPA. And the error is that we'll actually accept this and not this. We'll reject this one even though this is what's true. That's a type 1 error. Okay, if that example doesn't make much sense, let's look at some of these other examples that I have down here. Actually, I think the first example is one that Voigt has in the textbook. He does a good job of explaining type 1 and type 2 error. So he talks about a vending machine, and he talks about having a person with a dollar bill walking up to that vending machine to put it in. So a type 1 error is that the person puts in a real dollar bill and the machine says, no thank you, and rejects it right back out. So it's a real dollar bill. But the machine rejects it. That's type 1 error. Another example is a smoke detector goes off while cooking. So I don't know if this has ever happened to you, but it certainly has happened to me. So you're cooking something, and smoke detectors are supposed to detect the smoke of a fire. But you don't have a fire. Well, hopefully you don't have a fire. You're just cooking dinner. And perhaps the steam or the smoke from cooking over the stove sets off the smoke detector when you really want the smoke detector to detect a fire in your house. That's a type 1 error. You don't have a fire in your house. You're just cooking. But yet the smoke detector goes off. Another example of a type 1 error is a pregnancy test that measures positive for pregnancy when indeed an individual is not pregnant. That's a type 1 error. Rejecting a true hypothesis and accepting the research hypothesis that's wrong. A wrong research hypothesis. I'm not pregnant, but I got a positive. I have a real good dollar, but it got rejected. I don't have a fire, but the smoke detector went off. That's type 1. Now, of course, with the type 1, there's a type 2. We have type 1 and type 2. So here's another way to look at this with this matrix. Y usually represents the research hypothesis. Or, excuse me, represents the dependent variable. X represents the independent variable. So that's what you have in notation. So if you find that the independent variable predicts the dependent variable, and yet, so you have X, and Y happens. You're golden. The null hypothesis is false. You reject the null hypothesis. That's good. So here's when X leads to Y. And you know that to be true because you've done significance testing. You reject the null hypothesis and the null hypothesis is false. No error. When you hypothesize X leads to Y, but Y does not happen, you in effect have a true null hypothesis, meaning there is no relationship between X and Y. But you rejected the true null hypothesis. That's a type 1 error. For type 2, it's the other diagonal of the matrix. you have a null hypothesis that says X is not related to Y. X is not related to Y. That's the null hypothesis. And yet, Y does happen. That's a type 2, because you're saying X is not related to Y, you accept the null hypothesis, and yet Y happens. That's a type 2 error. So on the opposite side of those examples, Voigt talks about this in relation to that machine, that vending machine again. The type 2 is a little different. He says, okay, let's say now you have a counterfeit dollar bill. And the machine accepts that counterfeit bill. That is the type 2 error. It's accepted the thing that was wrong. The probability of the error can be offset by a large sample size. So there's a lot of benefits for trying to increase the sample size in your study. This is kind of counterintuitive information because it's so difficult for us to think in terms of a null hypothesis. No relationship exists. But that's what we're trying to do with hypothesis testing and significance testing. We're trying to show that we're trying to figure out, is there a relationship or is there not a relationship? And it's just the language of research that kind of gets us turned around sometimes. Let's look at some examples again. This is of hypothesis testing. This is, again, that same example we saw when we were looking at significance. What I wanted to show with this example, though, and this is tuition, how does tuition differ among community colleges based on whether they're rural, urban, suburban, based on their locale, or located in the town. And here's what the researchers reported in relation to these findings. Researchers reported that they rejected their research hypothesis, meaning they expected to find a relationship between tuition and community college locale, regarding differences in in-state tuition based on whether the community college was located in a city, suburban, town, or rural. They rejected their research hypothesis because they thought that there would be a difference. The reason they rejected the research hypothesis is because they found no significant differences statistically. So in other words, they could not reject the null hypothesis that there were no differences. And that's it on hypothesis testing. More when we get into actual statistics and looking at, when we run a statistic, what the significance levels are.